it has become very imperative that we make time to be able to learn these skills. Number one, to be efficient at what we already do. Number two, to sharpen what we already know to become better at it. And number three, to equip ourselves with skills that can gain us a job, whether with an employer or not. With these skills that we are about to acquire through this 5 days intensive machine learning program, you can be an entrepreneur of your own or on your own after you have graduated from this program. So we intend to empower ourselves through this program to be self-sustaining when it comes to job seeking, and then to be efficient in what we already do. It's two ways. If you don't have anybody to employ you after you have graduated from this program, you should be able to start something on your own or be able to do something by yourself that can generate money for you so that you can have a sustainable life. And on the other hand, if you're already doing something, these skills you're about to acquire are going to help you to become better at what you do and position you at the top among your peers. So it is important that we take this time seriously and we take this opportunity that we have gotten seriously and make the best out of it. It'll be important that we focus and we give it our all attention so that the 5 days will be worth the investment. You can look back on these 5 days and say that I didn't waste my time being here. Yes. So once again, I want to encourage us all to put in our ultimate best and draw the best knowledge out of this short period that we have. My second phase of what I want to say is that this program is divided into 3 sections. This 5 days marks the stage 1 of the program. We intend to start stage 2 somewhere in February. So let's take note that this 5 days is not going to be the end, but in February, we are likely to have phase 2. Phase 2 will start in February. Then somewhere in September, we'll have the last stage, which will be like the grand opportunity for us to embark on this journey. That's the time that a chunk of the things are going to come. So take every step seriously, and I want to encourage all of us to be a part of all the sessions and all the stages that we have allocated. Stage 1 ends, this week. Stage 2 starts in February, and then stage 3 to the final stage that will make you extremely proficient at what you do will be in somewhere September or July thereabout. July, September thereabout. All right. So quickly, I would like to hand over the opportunity or the platform to our facilitators, Hakeem and what's the name? Stephen. The team is led by Stephen, and they'll be taking us on an intriguing journey for the next 5 days. And I believe when we are done, we will have a good basis to build a very great future on. I want us to take note that there are going to be projects, there are going to be hands-on practices that we are going to be involved in. Let's take all of them serious. When we are done, we'll be awarding certificates to everybody that has joined. So please know that your participation is important to earn the certificates. Thank you very much. So Stephen, over to you now. Thank you.
Okay, thank you very much. We are about to start our journey on machine learning. And before we go into that, I wanted to first do an introduction to Python programming so that we have like a good understanding on the basics before we start building on it. Because if the foundation is not good, it will be very challenging to understand from the data analysis bit to the machine learning bits. So I would be taking you through the basics of Python first. Then from there, we'll move on higher. And for those who already have experience with Python, it would be very nice if you chip in some things so that everybody is on the same page and we can all move together smoothly and, of course, develop. I'm going to start by showing a quick video, not a video, but like a quick demo of what you can do with Python. I wish I could show something on machine learning, but I don't have one on my current machine. So I'll just show you something related to web scraping, which was built using Python, so that you can understand some of the capabilities of the Python programming. So even if you don't dive into machine learning, you can still dive into other areas using your programming understanding. And it's transferable. Once you understand the syntax, you can just apply the same understanding or the same concepts and just do in other programming languages. So allow me to share my screen and we can get started. Cool. Also, feel free to interrupt me if you have any questions. Okay, so can you see my screen?
Yes.
All right,
Yeah.
so this is a simple web scraping project that makes use of a lot of the things we are going to talk about in Python, functions, lists, dictionaries, all of those things, print statements, all of that. I don't think I'll go through, but I'm just going to run it so that you will see like some of the things you can do. So basically, this program is going online to a specific website to extract information from that website. In the machine learning space, there's something, there's data engineering. And in data engineering, there's something called ETL, extract, transform, load. And most of the time, one of the process to extract data is through web scraping. There are other ways of collecting data, but web scraping is one of them. So if you have a good understanding of web scraping, you are able to extract, use your basic understanding of Python to transform the data to have like a more uniform data across. Then you can load it into your database. And later on in the future, you can just pull that data, add value to it, and use it to train your model. So it's like an entire pipeline system on its own that if you have a good understanding of any of the components, you can contribute massively to a full machine learning process. So I'm just going to run this script so that you see like you get like a good understanding on what you can do with Python. So there's headless mode and there's the headed mode, but I want this to be visible. So I set headless to false. So in the script, I read from a file, and then in the file, I have a list of places or locations that the client is interested in. So when it opens the page, the first thing it does is it searches for that location that is in the file, and then it goes on to extract all the information there is about that particular project. So as you can see over there, this is what it does. It's navigating it as though it's a human being. You should also know that there are anti-scraping mechanisms on most platforms that checks if you're a bot or if you're a human. So if you are caught that you're a bot, they either block your IP or block your access to that particular web page. So it's good to try and simulate a human behavior as much as possible. And you can do all of that in your script. So that is an example of what has been done here. If you look over here, you can see that the data is being stored real time as it's being scraped. So this is like a good example of what you can do with programming. This is just to get you excited about what we're about to do. So I hope I've been able to excite you. Please, let's make it interactive. I want to hear from you. You can also talk to me.
Sure.
Yeah, so that is it. We can go straight into it. So, introduction to Python. The first thing you need to know in Python is variables. And variables are like containers, and it is used to store data. So if you look on, if you can see my screen, you can see that I have an example of a variable here that says number equals 5, me equals you, and language equals Python. Now, number over here is a variable, and 5 is the value that is being saved into that variable. So if I say number is equal to 5 and I print number, number will give me 5 because inside number is 5. Do you understand? The same for me and the same for language. If you print language, you get the value that is inside language. So I have a quick example here. The reason why I use Jupyter Notebook is so that we can have like a real-time interaction, so that like if I explain something, I can actually code it for you to see how it behaves. Then it's easier to understand. So I saved the number 10 inside the variable X, and the number 5 inside the variable Y, and I printed X plus Y. Who can tell me what will happen if I am to run this line of code?
You are going to get 15
Why is that?
because the 10 and the variable of X, right? Is it variable? The X is a variable, right? It's
Yes,
10. And then
yes,
Y is 5. So
yeah,
X plus Y gives you
it's
15.
15. Yeah, that is true. So when you run that, you see the response and the answer was 15. Now, we are going to have like do a quick exercise here where based on the response we got at the top there, we are going to try out and test our understanding. So what do we have to do? Yeah, we are storing the printed value in another variable, and we'll subtract 3 and store the new result in another variable called final. So based on this, we are going to have two variables, right? One will be to store the 15 that we got at the top, and the second will be to store 15 minus 3. Are you guys following?
Yeah.
So will someone help me, or do you want me to do it? Let me see if I can call. Lamte,
Yes,
please, can you please assist us with this step? So
yes,
over here at the top, we have X plus Y, which is giving us 15. We don't want to use the number 15. We want to maintain our variables. So we are going to create another variable that is going to store 15, but without using 15. Then we'll create another variable final to subtract 3 from the new variable that we created. So please walk me through it, then we can go faster. Hello.
Yeah.
Yeah, can anyone hear me?
Yeah, we can all hear.
You can hear
Yes.
you.
It's interactive. I want to do this with somebody. I don't want to do it alone.
Can I give it a try?
Yeah, please. You can.
So can we replace the 15 with X plus Y? Or we have to use another
You can replace the 15 with X plus Y, yes.
okay. So let's say X plus Y.
Okay, so we have to create a variable. Let's say the variable name is sap X plus Y. All right, what do you want to do again?
Then you said we subtract 3.
Yeah,
So let's say let's use another variable to represent 3.
okay, what variable do you want to use?
So let's say K
Okay, equals
plus
3.
3. Yeah.
All right,
Then we have X plus Y minus
okay, X plus Y minus 3. Okay, so final
yeah,
it was X plus Y minus 3, minus K.
minus K.
Yeah, that's what you want.
Yes.
All right, so let's print. Do you think you got it correct?
Yes.
Okay, good. You did get it correct, and congratulations, you have successfully completed your first Python program. So this is
Wow.
this is how variables work. So in Python programming, you would use this a lot because most of the time you would want to save information in your variable to use later. Down the line, we'll talk about other data types that we can use to manage, like to handle data. And that would help you have a good understanding. But variables are the basics. Every programmer needs to have a good understanding of variables because you would need them. There are different types of variables. We have the global, we have the local, and we have the non-local. So we'll go into all of that, and you know when to use a variable, where to place the variable, how you can access it, and all of that. So this is a good program that we've executed for a simple mathematical operation. And we'll move on to where we are going to look into why this is not working. So over here, we created a variable called name, and we assigned Stephen to name. And let me comment this out. If you run this line of code, right? So if you run this line of code, it's supposed to print Stephen out for you, right? It's supposed to print Stephen for you. Sorry that I ran that long. It's supposed to print Stephen for you. If you run it with this line, it gives you an error. Now, why does it give you an error? There is something called Python keywords and identifiers. And what you need to know about Python keywords is they are words that are usually reserved for Python programming. The compiler has the understanding of these words have been hard coded into the compiler. So if you run the compiler, it's going to interpret that as the meaning that has been given to it. So if you create a variable with any of these names and you run it directly into the compiler, it will give you an error like what you saw over there because it understands it for that particular meaning that has been given to it. The reason why I had to put this line over here is so it will run the code directly as directly in the Python compiler. Because if you take this out, if you take this out, it will run normal. That's interesting. Okay, that's interesting. Yeah, so it won't work. It won't work. So basically, continue is a keyword that is used in Python and it runs only in loops. You get it? So you can see the error message here saying continue can be used only within a loop. Do you understand? So if you use something like break is also another keyword that runs inside a loop. If you use import, it's also a keyword that runs inside, sorry, that works only for the Python compiler. So it is good to have a good understanding of these keywords. It's not a lot, so you can keep them in mind. And or if you are even writing your code and you use any of these keywords, it will give you an error. And you know that, okay, if you still want to use import as your name, you can add something to make it different from what is already in the system. We can now go into how to change the values of a variable. So as we explained earlier on, a variable is a container. And if you save something in a container, you can just remove that and put another one in there. And that is how it works here. But this time, instead of removing, you can just assign a new value to the element. So if you look over here, you can see that we created a variable called site name. and in there we saved kaizenacademy.com. If you print this, it's going to give you kaizen.com. But if you run another line of code where you save something else into that same variable, it will replace or overwrite what you initially did. Also, you need to understand that the compiler executes down. It doesn't jump. So if 1 and 2 says site equals Kaizen Academy, and 5 is saying the same site name is assigned to something else, it will overwrite what you did in 1. Do you understand? So if you run this, you realize that, yeah, I'm printing this. It's not sure. You realize that site name has changed. It is no longer Kaizen Academy. It is now apple.com. Do you understand? So that is how changing of values work in when you're working with variables. So in the future, when you're working on a project and you don't want to create multiple variables, I mean, it is good to have dedicated variables, but there are some variables that maybe you can change their values from time to time. Maybe you are doing a calculation and you want to do 1 + 2 + 3 + 4, and you are saving all into the same variable. You can say, okay, total is equal to 1, then do total is equal to total plus 1. That would be total equals 1 + 1. That would make it 2. So now total becomes 2. Then you can do again total equals total plus 1. Then it goes on total. I'm confusing myself, but I hope you get what I'm trying to say. So it's a good understanding. It's a good way to implement certain features. Yes, Isaac.
Thank you, Stephen. So if you go up, you realize that for, let's say, continue, or even where you had name,
Yeah.
You put the Stephen,
Yeah.
right? You put it in double quotes. Now you come
Yeah.
down, and then we are seeing Kaiser, is it Kaizen Academy? Yeah, KaizenAcademy.com in single quotes. Why?
Yeah. Okay, so I was going to touch that down, but I can talk about it now. We have a data type called string, and in Python, strings can be created using either a single quote or a double quote. In another programming language, like let's say C++ or Java, a single quote is used to represent a character, and a double quote is a collection of characters, which is also a string. So if you look at the 7 at the top here, which is the double quote in Python, yes, that is a string. If you look at the single quote down here too, it is a string in Python, but then you need to understand that it will not be the same representation in a different programming language. Okay. I hope that is clear.
Yes, that's clear.
Yeah. So in Python, you can use either double quotes or single quotes. Another thing to know is this can also help you create, let's say, a string where you have 2 different types. So example, you have a sentence, and in the sentence you have a quotation in there. And let's say I want to write something like, this will not work. This will not work. Because if you open a quotation and it sees another quotation, the compiler will interpret it as that being the end of that, like the first quotation. So to be able to work around something like this, you can switch the quotes. So you can either use single quotes out here, and this would work, or reverse it where double quotes will be out and single quotes will be in. There are other ways to around it where you can just put / in front of the double quote, and that would also help the compiler understand that, okay, this is an inner quotation and not the ending of the first quotation. So these are all different mechanisms that you can employ to make your life easy. Do you understand? So Python strings can be either double quotes or single quotes. Are we all on the same page?
Yes.
Yeah, okay. So we can do more examples on how to create variables. So you can have a case where you have ABC and you assign accordingly in that same format, 5, 3.2, and hello, and you're not limited to the particular type. It doesn't matter if it's a float, it doesn't matter if it's an integer, it doesn't matter if it's a string. Anyway, as long as it's in that right format, it will work out. But if you add a fourth when the variable is just 3, you will get an error. So it should always be the right number. So we see that it works. Okay, so you can see A is now 5, B is equal to 3.2, and C equals hello, as we have declared. There's also another case where you can assign 2 variables to the same value, and you can say site1 equals site2, which is equal to your value. So if you run this, you see that it prints site1 as Kaizen and it prints site2 as Kaizen. But I put a comment here that this approach is not often used in the real world. And well, that is in my experience. I've not really had to use this approach, but there will be a case in the future where you come across a project that would require you to assign the same value to 2 variables, and you can use this approach. Now we go into type conversion. So earlier on, I mentioned that we have different data types in Python, and in type conversion, it's a type of conversion where you have to change the data type from one format to another. So let's say you have an integer and you want to work with strings. You can convert an integer to string. Let's say you have a float and you want to work with it in the form of an integer, you can convert from float to integer. But then there are 2 types of conversion. There's the implicit conversion where Python will automatically do that for you. So Python by default work with integers when it comes to numbers. So if you don't really define that, okay, I want to work with an integer, if you don't define that you want to work with a float, sometimes it will just convert it to an integer for you, depending on your usage. So it is good to have a good understanding of these. And explicit is when you manually convert. So like, for example, integer to string, those 2 are different data types. They're not in the same family. So you have to manually cast it from one type to another. So I'll go into implicit. So this is an example. You have an integer number 123. You have a float, which is 1.23. Now, if you do a summation of the integer and the float, you would get the 2 together. The type was changed automatically from an integer to a float. So this is Python automatically handling the conversion for you. You understand? Are we on the same page? If you have any questions, you can ask.
Please, could you take that part of it again?
Okay, so if you have a decimal number, right? In Python, that is interpreted as a float. Okay, so if over here I have a variable called float number, and in there I saved a decimal number. Okay, let me, yeah, and in float number, I saved 1.23, which is a decimal number. So that is a float. If you check the type of float number, it will tell you that it's a float. If you run this, it will tell you the type is a float, okay? And for integer number, it is an integer. So if it is a whole number in Python, it is known as an integer. Now, what Python does with this implicit conversion is, if you pass an integer and a float, automatically your answer would be a decimal. So the new variable that you create would have like that new data type. Does it make sense? So if you run new number, It will tell you it's a float. But then if you want to change this into an integer, then you have to cast it. You have to cast it to convert it from a float to an integer. Is it clear or it's still not clear? Hello.
So basically, you can switch between float and integers. And if you want
Yes.
to switch float to integer, you need to cast it.
Yes. Yes, that's exactly it. But this, what I just showed you is explicit conversion, where you manually have to do it. But then by default, Python can handle some of the conversions for you. So let's say if I create new number, right? And I assign new number 1. The type for new number is now integer, right? But if you come and run this code, new number equals integer plus float number, the type will change from int to float because of the value you are assigning to it. So that is the implicit conversion that Python is doing for you. So with these type of simple addition, multiplication, and calculations, Python can handle those things with ease for you, and you wouldn't have to manually have to convert. Do you understand? But then when you have like an explicit case where, okay, the final answer you're getting is in decimal, but then you want to work with float because let's say you want to run a loop, and if you run a loop with a decimal, it will give you an error. You have to cast it into an integer to get what you need. Do you understand? So that is a use case where you do the casting. So another explicit use case is when you use Python inputs. It gives you string by default, but then you can cast that string into an integer to be able to use it for your calculation. So if you look over here, num string is a string. So you can see my single quotes there, which is telling me that the 12 is not a number, but it is kind of a word. Do you understand? And num integer is 23, which is a number. If I print the data type for num string, it will give me string. But if I hit if I run the type for num string, yeah, it will give me a string. So let me comment these out so that we confirm what type we get if we run. So it says it's a string. Now you can't do calculations with a string. So if I say let me print it first. 2 plus 2. This won't give me 4 because it's a string. If I run this, it will give me 2, 2. So it's concatenation, which is a term under strings. So it's one of those string methods that can help you add 2 different words together and you can separate with a space. So however the strings are, if you concatenate, it just puts them together to give you 22. But if I want 4, I need to have 2 numbers, which will be int of 2, int of the string 2, and int of this string 2. And that will give me a 4. Does it make sense now?
Integer 2 plus integer 2, making 4.
Yeah.
Yeah, it makes sense. But you can also do 2 plus 2 and it will give you 4, right?
Yes, you can do 2 plus 2 directly and to give you 4. Now the reason I'm showing you this is if you use this, where is it? So let's say you want to input. You want to set a user input, right? All right, let's see what we get when we run this. So let's say 2. It gives us a string, right? So if I want to build a system where the client, or sorry, the user will provide information like numbers. Let's say I'm doing a calculator and I say input a number, let's say 2 plus 2, right? And you enter your first 2, it asks you for your second number, you enter your second 2. In the system, it understands input values as strings. Okay. If you want to convert the user's input into a format you can use, you would have to cast it. So by default, input will give you strings, but to be able to work with it in a numerical form, you have to cast it into a number. So you can do that by maybe casting it directly over here, like saying as an int. And with this, when you check the type, you see that, okay, let's say 3. You see that the class is now an int. Do you understand? So this is to just help you handle the data however you want. Does it make sense?
Yeah.
Yeah. So this is a good use of type conversion. So I just touched on input. So input is to just input is to just help you like get the user to put in data. So you can have the user type in a sentence, type in whatever, but you have to make it such that you can control it so that in your scripts you can execute whatever you want to execute. Do you understand? So I just touched on inputs. With input method, you just type input, you create your open and close brackets, and you put into the bracket what you want to ask the user. So if I'm to run this inside command prompt, you see that it will open, like it will give you an interactive window for the user to type in something. So when you finish typing, you run, then it executes whatever that it needs to run. So let me show you an example in my command prompt. So let's say I've initiated Python. Let's say input something. When you run this, it will ask you to input something. So until you type, I make like a little bit. So all right. So now you get something. So input something. Let's say automatically it's treated as a string. Do you get it? So this is basically what I'm talking about. So input does this for you. If you want to work with it in an integer form, then you cast it. Also, you need to know that you can't cast letters into numbers. It will give you an error. I've not tried that, but I believe it will give you an error. So we can explore that together right now. So let's see. Yeah, it will give you an error because it can't handle this mathematically. So we need to also pay attention to what we are casting when you are writing like a much more elaborate system. So this is a good understanding, a good example of how to use inputs. Now there's something called Python operation. So with Python operations, you can do, you have like symbols for doing comparison, like conditional statements, assigning operations, arithmetic operations, all of that. So I think there are 6 of them, and I'm going to take you through all of that. So for Python arithmetic operators, you have the additions of that.
I have a question.
Please ask your question.
Okay, so the input, what we just did, okay.
Yeah.
Does it mean that if you enter, let's say, a string,
Yeah.
it will be, it will give you, a wrong input. Let's say you are on a user interface and you are trying to, you need to type a number, your phone number, and you type your name. That is what this means, right? When you type your name on the user interface, it gives you a wrong listening because you are supposed to type a number.
Okay, yeah, okay. You can do that too. So input by its default makeup is for you to input something. It will ask you to input something. So as to what you type, it has no control of. You get it? So you can type whatever that you want to type. So you are given the option, like the programmer is given the option to make it more defined for you. So I said enter a number. Do you understand? So it will ask you enter a number. If you enter, let's say letters, it can't do anything about that. So you would have to have another condition in your code to check the kind of input you get. Okay, so check if this input is a string, check if this input is an integer before you work with it. So if I want to do a like some calculations and I say enter a number and you put in A, I need to have a condition to check if this is an integer, then add A plus A or B plus B. Do you get it? But if it is not an integer, continue, break, print an error statement. It is up to you how you want to build your system. Do you understand? So input has just is implemented for you to ask your user to give you some information before you can proceed with your system. So until the user types something, the system will not break. It will just constantly wait until the user comes to type something before it can proceed with the rest of your lines of code.
No, fair enough.
Yeah, okay. Anybody has any other questions?
So is there any way you can define the input section to have only a particular code? Let's say it should only be strings. I mean to say letters or figures.
Sort of. You can, I won't say can't, but with the current version of Python, you won't be able to define inputs. Like I want inputs to give me an integer, but then you can cast the value in input to be an integer. Do you understand? So if you look at this example over here, on that same line of code, I said cast whatever I get in from input to an integer. So by this, I am converting the input value into integer straight up from when you enter it into the system. So when you enter it into the system, it will come as string, but then it will save it as an integer into my variable. Do you understand?
Okay. Yes.
Yes. So that is how you can manipulate your data types when when you're using an input. If you want it to be a string, you can leave it like that. But if you want to change it into an integer, you can do that. If you want to do a float, you can do that too. So it's all up to you.
So to cast literally is all about just you putting in whether you want it to be an integer or otherwise in front of the input.
Yes. And there are also rules that guide casting. So I think that can be an assignment for you you want to go do. But basically, let's say if I want to cast, so we have something called sets, we have something called tuples, we have something called lists. These are sort of in the same family. So if I want to cast from a list to a tuple to a set, it is easier to just do the same thing. So just like I did int and into brackets, the value, you can do the same thing for these type too. But if you try to cast a set to a list, it will give you an error. Or if you try to do integer to a list, it will give you an error because they are not of like the same type family, sort of. Do you understand? So that is also something that we have to look into. So I'll go further into that at the bottom when we are done going through a lot of exciting stuff. So I'll go into the Python operators. Then after that, I think we can have do a quick trial and let's see if we are all on the same page and understand what we've done so far. Okay, so with the arithmetic operators, it is like I said, basic math. So addition, subtraction, multiplication, division. Yeah, and there's something called flow division in Python. I'll go into that. Then we have modulo and we have power. So power is the exponential stuff. So if you want to do basic addition, you can just use a plus sign. If you want to do subtraction, you use the minus sign. If you want to do the multiplication, you use the asterisk, and the same for the rest. So I have, again, done a code example here so that we can easily go through and see what each of them will do. We already know what addition will do. So if we say a plus b, it's going to give us 9, which is 7 plus 2. If we do a minus b, that would be 7 minus 2, which is 5. If we do a with the multiplication symbol and b, it will multiply 7 by 2, which is 14. If we do a and a slash b, I think this is backslash b, this will do a division for you. So it will divide the 7 by 2, which will give you a decimal number. And floor division, the interesting thing about floor division is floor division will give you a value without, by default, it will convert your float to integer for you. So if your response is supposed to be a decimal number, it will take away the decimal bit and give you only the whole number. So if you do 7 divided by 2, it should give you, I think, 3.5, but it will take away the 0.5 and give you only 3. That's what floor division will do for you. And then modulo is more of a remainder, yes. So if you divide, let's say you have 10 and you divide 10 by 2, how many times will 2 go into 10? That's 5 times. It's a whole number. So the value you get for modulo will be 0 because there's no remainder. But then if you do modulo and there's a remainder, that's when it will give you a value, something which is not 0. So usually we use this for maybe even numbers and odd numbers and those stuff. It is up to you. Then there's power, which is exponential. So 7 divided x, 7 exponents 2. And it will give you the value for that. So I'm going to run the code and yes, please, Andrew.
Yeah, so if I get it, it looks like the floor division gives you the whole number, and then the modulo gives the remainder.
Yes, exactly.
Right.
Okay, so I'm going to go into that. Give me a second. So I'm going to run that for you. So you have 1 over here for modulo, because if you do 7 divided by 2, it will not give you like a whole number. It will give you a decimal number. Do you get it? So it gives you the remainder for that. So summation, subtraction, multiplication, division, floor division, and exponential with modulo. So this is a good operator to use depending on the kind of use case you are working on. So you can make good use of all of these things. If you want to do a calculator, you can just make use of the arithmetic operators and to make your life easy. If you want to go further into maybe work with prime numbers, maybe work with even numbers, work with odd numbers, depending on your use case, you can use this accordingly. Not recently, but there was this project that we got at work, and we wrote like a long ass if statement, check if it is this, check if it is that, check if it is this. And it was about 30 lines of code. But later on, after we went through the code to try and optimize it, we realized that we can just use floor division to make our life easy. And that cuts down the 13 lines of code to just 1 line of code. And that was impressive. When we did that, we were so excited. We were just laughing. Hakeem was on the call. You can ask it. It was so funny. We're like, can you imagine? We sat there, wasted time doing copy and paste. Then we change the condition, copy and paste, and we change the condition. Then we come and find out that we can just use floor division to get what we are looking for. I was like, come on. So it is good to always visit the basics. It's good to always visit the basics, because there are some things that you can easily implement if you have a good understanding, a good foundation of the Python programming language. And this, in my case, this was very helpful in optimizing my system. So there's also the assignment operators. We have equal to, we have the addition assignments, we have the subtraction assignments, multiplication, division. So just like the way you do your A plus B, if let's say A is my variable and I want to just add B to A, I can just say A plus and equal to B. Ignore the error. So I can just do this and it will give me A equals A plus B. That's what will happen. So I will go through the example down here and you can have a much better understanding. So if you look over here, okay, so this, when you look here, it's what I'm trying to explain to you. So it will give you A equals A plus B. So this will be repeated. So it's like you're trying to tell me that you want to add B and at the same time assign the value of A plus B to the same variable A. So that is what is happening here, assignments, addition assignment. So if I run this, the output should be 15 because I am adding B to A and I'm assigning the value of B and A's addition to A again. So I'm going to create one here just to test that we understand this operation. We'll use the same AB, but then this time we'll do multiplication. So I want someone to help me with this. We are multiplying A and B and saving the value in B instead of A this time. So how will I go about with this, taking into consideration assignment operators? So can someone step in and help me?
Okay, let me give it a try. So
Okay.
we'll do E, we'll give the variable E to be equal. Yeah, you mentioned E, right?
No, B. We want to save it back into B.
Wow.
Yeah.
Okay, let me go ahead.
Okay.
So B, multiplication sign, then the assignment sign.
Yeah.
Then we put A.
All right. So this is, let me run it so that, no. Oh, sorry, friend. Okay. Do you understand what happened here? So with this line of code, what we are telling Python to do is we want a variable called B. And inside the variable B, I want you to store B times A. That is what this line of code is doing. So instead of typing the long B equals B times A, you can just use multiplication assignments to simplify your program. Then you just have a simple line of code and it will do exactly what you want. Is it clear? So, Pastor Ivan,
Yes, please.
assuming we want to do the same thing but save it into A this time, what do you think would be, how would you approach it?
I'm not so confident with the language you use, but I think A will come first.
Yeah.
With the star.
Okay.
Equal to.
Yeah.
B.
What did you say? B.
Yeah.
Okay, so this is correct. So with this, what you're asking Python, can you please tell me what we are asking Python to do? I don't repeat it.
We want it to save the final details in A.
Yes, exactly. So that is what we are asking Python to do. So yeah, this is what we are asking Python. So you can use this operator format in a lot of your implementation. Sometimes you'll be running a while loop, and in the while loop you are checking for the value of a number. And so let's say you are saying that if or while I is not 10, don't stop. That's what your condition is saying. So now in your count, your I count, you can say I plus equals 1, and you just simplify the whole process. So every time your loop runs, it just adds 1 to I. So adds 1 to I, adds 1 to I, adds 1 to I, until I is 10, then your system will stop. Do you get it? So this is a nice way of implementing something, and it makes your life simple. There's also Python comparison operations. And this is just using the equal to signs and the exclamation equal to sign. That's just like not equals. So over here, if I want to compare if the value of A is the same as the value of B, I will use the double equal to. If you use a single equal to, you are doing a variable assignment. But then if you use a double equal to, you are doing a comparison. So with this line of code, this is string format. String formatting. That's why it's like this. But basically, what we are asking the system to do is to check if A and B are the same. Do you get it? So if, sorry. So if I run this, it will tell me that A equals B is false. Why is it false? Because 5 and 2 are not the same. So that's what this script is doing. So it checks that and gives you a Boolean as a response. So Boolean is usually true or false. That is what is used in programming language. So for cut across every programming language, if you hear Boolean, Boolean, we are talking about true or false. So if you run a comparison here to check what A and B is holding, if it is the same or not, you get responses accordingly. So if I change this to 5, you realize that it will change from false to true because now A's value is the same as B's value. Do you understand? In the same way, if you use not equal to, which is exclamation equals, then it will tell you accordingly. So now we know that 5 and 5 is the same, but this place is saying A is not equal to B. But we know it's equal to B, so it will become a false. It will make this statement false. But then if this was true, then this statement becomes true because A is not equal to B. Does it make sense? Any questions? Yeah, so that's how that works. Then we have the greater than and symbol, less than. That also does the same thing. It checks if A is greater than B, it gives you a response. So if the statement is true, it prints out true. If the statement is false, it prints out false. So there's A is less than B. We know that this statement is false because A is 5 and B is 2. And we have A is greater than or equal to B. And we also have A is less than or equal to B. So these are things you have to pay attention to. If you are doing conditions, you can use these things to check and manipulate your stuff. So it's good to know them, how to represent them in Python. If I want to check if it is greater or equal to, how do I do it? You know that this is the operator to use and your life is made simple. So you just do this and you go on. There's also logical operators. If you have any question, please ask before I move on. So far with everything we've covered, if you have any question. Oh, we are all good.
Yeah, we're good.
Okay. There's Python logical operators. Now, this is based on the AND and OR and logical operators. So now it's good to know that AND is inclusive and OR is I don't want to say exclusive, and because that's wrong. And OR is if any is true. Okay, so let me go into it further to make it easy to understand. If I say true and true, your statement is true because both statements that you are checking are inclusive, so they are both true. So your response will be true. So if I have like a condition, and let's say I say 2 equals 2 and 4 equals 4. They are both true because 2 is the same as 2 and 4 is the same as 4. So that will give you a true. But then if you have a true and a false, you'll get a false because it is not inclusive. Is that clear? Or let me go into it further with examples.
This is just like when you do positive equals positive,
Yes,
negative.
Yes, negative 4.
Yeah.
just like that. Yes. Thank you very much. So that is how this works. It works the same everywhere. So the or statement is when you are checking if any one of the statements is true, and the end statement checks if both statements are true. So again, if you have a conditional statement, that is, let's say I want you, the code, to check if this condition is true and that condition is true before you go. So you can say that, okay, let's say you have a student management system and you want to use attendance and the person's final grade to say that, okay, this person has passed the semester and they are moving to the next, let's say the next year. You can check, okay, is the person prompt in terms of attendance, is their attendance score high and is their grade score high? So, okay, their grade is above 90. That is a true. Their attendance is above the number that is supposed to, the minimum number they are supposed to be in the office. That is also a true statement. Then your system will say, okay, this person can graduate to the next year. So depending on how you want to implement your condition, you work out your logic accordingly. So, and there's also not true. Not true automatically will give you false, and not false will automatically give you true. Then we have special operators. There's the is and there's the is not. This is also nice to use from time to time. So you can say xy is not y1, and that is a false because 5 is actually 5. Does that make sense? So the variable x1 is 5, the variable y1 is 5. So these two are actually the same. So x1 is y1, not x1 is not y1. So you have to take that also into consideration. These two are also the same. So if you say is, it will give you a true. This is also the same. If you say is, no, this should be a true. Yeah, this should be a true. Interesting. Not sure why, but does anybody have an idea why this is a true, this is a false and not a true? Any of experts can help, or I can look into it later and get back to you tomorrow with a response. Yeah, so I'll do that. I'll look into this and get back. This is actually lists. This is an example of what a list looks like. And a list is usually also a container, but a list contains multiple values. So as you can see over here, there's 1, 2, 3, and each of them is being saved in a different memory address. So if of that particular list. So if I want to get the value of 1, there's a particular index that I use. Usually list starts from 0. So index 0 will give me 1, index 1 will give me 2, and index 2 will give me 3. So that's how list works. I'll look into why this is not the same. I think I'll look into that to be sure. Then I will come and convey that information to you all. Then there's the membership operator. So there's in and there's not in. Usually I use this bit a lot in list set tuple operations when you are running a for loop. So you can say if 1 in x3 or if 1 in y3, it will give you a response. If it is not in it, it will give you a false. So over here, it says if H is in X, like I said earlier when I was talking about strings, strings are made up of characters. So hello world is actually H, one character, E, one character, L, one character, L, another character, then O. So that's how it is. So if you write a statement like H in X, it will loop through the string hello world and check if H is in there. The same thing applies to if you are looking for the full statement hello. So it works for list, for set, and for tuple, because that's how those were designed to operate. So that is how the in works. Not in, that's also the same thing. So the opposite of that is it in, it's not in there. So if we know hello is in X, but the H is a capital H, not a small h. So this statement will be true because this hello is actually not in X. So that is how it is. So if I run this, it will give you a
Steve,
true,
hello?
true, false. Yeah,
Steven?
I can.
Yeah, so the reason why it's giving false.
You've looked into it.
Yeah.
Thank you.
It checks when you use S, it checks to see if the element is in the same memory, the same allocated
Memory
space.
location.
Yeah. So
Okay.
if they are not in the same, although they are the same elements, but they're not in the same memory space or memory allocated space, so you get a false.
Okay. Is it clear to everyone?
Should I repeat myself?
Hello,
Yes, please
have you?
repeat yourself.
No, please come
Okay.
again. Come again.
Okay, so when you store when you assign values to variables, it stores itself in the memory. It's a particular part in your memory, right? So X3 is in a different memory space and Y3 is in a different memory space allocated to it. So when you use the S function, the S special method, it checks to see if the X3 is in the same memory space as Y3. But since both of them are in different memory spaces, it's giving you false.
So
Am I making sense? Okay, yeah.
So
how do
why
you bring them into the same memory space for
X2
it
and the
to
Y2?
agree?
Come again? I
Andrew,
didn't
can
hear
go
you.
ahead.
All right. I was asked why didn't that happen with the second one, the X2, Y2?
X2, Y2.
Yeah.
I got a true when you printed that.
Yeah.
Oh, let me look into that.
Thank you. Okay. So should we wait till we get a response for this before we move further? Because this is an entirely different topic on its own, if conditions. What do you guys say?
Okay, so please can you hear me?
Yeah, I
Yes.
can hear you.
Yeah, so I think whilst you are going on, the research can still be done at the background, and we can always fall back to get the explanation, and then we can still continue.
Will it come again?
Yeah, we
Yeah,
can
I'm suggesting we can continue whilst the research is also done by the rest of us. When we get the valid explanation, we can just go back and then explain to the class why it's false.
Definitely. Okay, for sure, for sure. All right. Okay, then.
Oh, okay. I have gotten.
Okay, please stop.
Yeah. So according to what I have read, it says that for small strings, like hello is a small string. So for optimization purposes, to optimize to make everything faster, Python internally handles that string, like the strings. It internally handles it without allocating it to a memory. So it just calls it again from Python, not from the memory. Unlike the list you declared in X3 and Y3. That one was sent to the memory, the system's memory. But for the hello, since it's a small string, it's not much and doesn't need any allocation. It's for optimization purposes. It's just handles it internally inside the Python, in the Python interpreter. I don't know if I'm making sense. If you guys are understanding what I'm saying. Hello?
Is everyone on the same page? Is it clear to everybody?
I think let's
You
come
know
back
when
to that.
Okay.
later.
Okay.
All right. Okay, no problem. All right. So if else statement. I've been mentioning conditions, and in Python, this is how you actually implement conditions. So if you are building a system, right, most of the time, every system I have seen, there's some kind of condition in there to check, okay, is this data like this or is it like that? Do this. If it's like that, do that. There's always some kind of condition in there. And I have done an example in my markup saying that if the percentage is above 90, assign grade A. If it is above 75, assign grade B. And if it is above 65, assign grade C. That is what the statement is saying over there. We have if statements, we have if else statements, and we have if else statements. Now, if you have a simple statement that you want to check, then you can use the if statement. That one you don't need to like have like an else statement to check like the external cause. It's just one simple statement. So if the number A or if the number 10 is greater than 2, then do this. So that's what the condition is doing. It's just checking that particular one. So I have a simple example here to help us have like a good understanding of what the simple if statement does. So we have numbers over here and the value in there is 10. Now we are checking the condition for we are implementing a condition over here, and the condition is saying that if numbers is greater than 0, then print number is positive. So that's what the condition is doing. So if I run this line of code, it will go into this condition block and print number is positive. But then if I change the value of 10 here to, let's say, -1, number now becomes negative. So numbers is no longer greater than 0. It becomes less than 0. So if I run this line of code, instead of it printing what is inside the condition, it will skip over to the print completed. Do you understand? So if you are using if statements, when you use if statement, what you're actually trying to do is, okay, I have a line of code, but then I don't want this line of code to run until I meet this condition. So run until this condition is met, then execute this line of code. That is how the if condition works. So until your condition is met, the line of code inside the condition will never run. So if this goes back to 10, condition has been met. So you get what is happening in there. Yes, so this what I just showed at the top. So that's how it works. If else statement is check if this condition is met. If this condition is not met, do this for me. That's how this works. So if this is how the syntax of if else statement, this is how it looks. So the if you put a condition, but the else you don't put a condition. So the same structure. We say check if number is greater than 0. If number is greater than 0, print number. But if it is not greater than 0, then print negative for me. That is how it works. So if I run this, since 10 is greater than 0, I will print positive number, but I won't touch negative because the first condition has been met. But if the condition is not met, automatically it will skip that condition and go and run else. Because if the condition is not met, I want you to do this for me instead. So that is how this operator works. Do you have any question for me before I move to the next?
I think this is very clear.
Okay, beautiful. Then the last one is if else statement. So with this, you can have multiple conditions. And if all of the conditions are not met, that's when else will step in to run. So you can see the syntax of if has a condition, elif has a condition, but else no condition. So that only executes when everything has not been implemented. So again, we check, is number greater than 0? If yes, it will give you positive number. If yes, it will give you positive number. If no, it will check the next condition. Is number equal to 0? If yes, it will print what is there for you. If no, it will go to else. So that's how it works. You can have a lot of else statements. Okay, if that else statement don't work, you can go to another else statement and another until all the conditions you've implemented are false before it will execute else for you. So with this, our number is 0, so it will print the else statement for us, which is 0. If we change this to, let's say, 2, it will print which one for us? Can someone tell me?
The first one, if number is greater than 0.
Yes, exactly. So it will print a positive. But then if all the conditions are not met, which is the 0 and the 0 equation, and the number equals 0, it will give us negative because all these conditions are not met. So do this one for me then. That's how it works. So that is if statements. There's something called nested if statements. So with nested if statements, it's the same mechanism as what we just went through. But this time, instead of printing positive, printing negative, it's just running another if condition for us. So the code is going to basically say that check if number is greater or equal to 0. If it is greater or equal to 0, check if the number is equal to 0. Do you understand? So that is how this condition works. I think this example will make it a bit difficult, but I don't know if it's clear to you guys, but over here, we are saying check if it is greater or equal to. That means if your number here is 0, this condition will be triggered because number is equal to 0. Do you understand? Yeah, so that is what is happening here. So if number is greater or equal to 0, so if number is 1, it is greater. If it is 0, it is equal to. So those two conditions apply. Now, if it is actually 0, check if the number is 0. If it is 0, it will tell you number is 0. If it is 1, 2, 3, 4 going, it will tell you that the number is positive because the 0 condition hasn't been met. So you have an inner if-else statement. But if all of this is not met, that's when the code will execute this. So that's how nested if statement works. So from time to time, you can find yourself in a case where you would need to make good use of nested if statements. And once you execute that, you get the desired results. Are we all on the same page?
Yeah.
Okay. Do we have any questions? I would like us to take a quick 10 minutes break, 10 to 15 minutes break before we continue for loop.
Can we make the break just 10?
Okay, yeah, that 10 works.
Yeah, so that we have the remaining, I think, 50 minutes. Yeah, we are done.
All right, for sure. So we can go for a 10 minutes break, and when we come back, we'll touch on for loop, while loop, and the rest of the stuff, strings, ends, dictionaries, sets, tuples, lists, all of that. Go into there, and we'll be done with this. We'll talk about object-oriented programming, then start machine learning. So we need to have an understanding of all of this before we are good to go. So thank you guys for listening. I'll still be here. If you have any questions, please hit me up and we can discuss.
So we'll be back by 12:10. 12,
yeah.
10.
Yeah. Okay, so I have a much better understanding of these bits, and so I want to go over it so that we are all on the same page. Is that cool?
Yes.
So, all right, cool. So like Hakeem said earlier on when he did his research, this is usually used for checking if items in the same location or if items in the locations, like different locations, are the same. Now the reason why X1 and Y1 it would work the way we are thinking is because in Python, right, there's a limit from numbers from 0 to 256 inclusive. Will give you like that kind of behavior. Anything above that, it will save the number in a memory location. So if I was testing that out over here. So I put 256 in here and it gave me true. So A is B. So this is treated like a normal variable. But then if it goes beyond 256, so let's say 257, it will give you false because now the values for each has exceeded the limits that they have set into the Python compiler. So now this A is being saved in a different memory, B is being saved into a different memory, and the address for each of the memory for A and B are different. So it's going to give you false. Does that make sense?
Yes.
Hello, are we on?
Yes.
That makes sense.
Yes.
Okay, the same rule applies to strings. String limits ends with 5 characters. Anything above 5 characters, it will save the data to memory. So if you run x2 is x1, if we change this to, let's say, hello world, we will get false instead of true, because now Python has seen that this string is heavy and needs to be saved into memory location. So now it will be checking the memory address for x2 and memory address for y2. So that's how it works. But list by default is not being treated like that. Every new list that is created is assumed that you're going to put a lot of data in there. So once you initiate a list, Python by default will get a memory location for it and it will save it into, like, it will save the whatever value that you put into that list into that same memory. So that's when you can do list operations like append. So if you append, it knows that, okay, there's a memory address. We have that memory address. So get this data or this new value and go and put it into that same memory address. And when you run or when you print that particular list, it has all the information there is that is tied to that particular list in that same memory address. So it will give you that result. So X3 and Y3 are in 2 separate memory addresses. That's why it was given as false. So it's not necessarily checking if the value is the same. It is checking if the address is the same. Does that make sense?
Okay, yeah.
Yeah, so that is how that's how S works. So I would advise that if you are going to use S, use it when you are checking if an address is none. And if you want to compare if the value is the same, use the equal to symbol. So if you want to check if A is equal to B, use this instead of this. But then if you want to know if the memory address of A is empty or if it is full, then you can use a slab. And that is much more helpful. Are we good?
The none option. I think you should take that part again. But
Yeah,
I understand that
none is,
if you want to, yeah.
None is empty.
Okay, okay.
Yeah. So if you use the S operator here, it will check if the memory, it will check if this address is empty.
Address the same.
Yes. So
But
if it checks
equal to, it will use to see if the variables they are the same.
yes, it will no, equals will check the value, but then S will check the memory location.
Yeah.
Okay, so if we say A is none, by default, if nothing has been put inside A, that location will be empty, so it will be none. So
Okay.
it is best to use S if you are working with none. And it is best to use the equal to symbols if you are working with like comparing two values.
Okay.
So this is like something that you can keep in mind when you are working or you are building your own system.
Okay.
All right. Excited. Okay, so now for loops. So loop, just like the name, it's like repetitive. So if we have two types, we have for loop and we have while loop. With for loops, you have to define it. It has to be bounded by limit, so or a range. So in this example, I created three different kinds of for loops, and each of them I had like a defined range. So the first one is just saying that I want a loop where I'm going to the number, or I'm printing the number I 10 times. That is what is happening. The second one is saying that I want a loop where I'm printing the number I 10 times, but I'm starting from 1 and I'm ending at 9. That's how this one runs. And the last one is saying that, okay, I want a loop of 10, but then I want you to skip the intervals of 2, start from 1. So if I run these codes separately, you will understand the behavior. So with this one, every loop starts from 0. Every loop starts from 0. So that's how Python works. Most of the time, indexing, it starts from 0. So this I will start from 0. It will go 10 times, but it will start from 0. If I run this second line of code, it will loop 10 times, all right, but then I've set it to start from 1. So instead of it starting from 0, it will start from 1 and it will end at 9. So that is how this works. Usually the ended number is not inclusive. So it will stop the number before that. So it checks, is it 10? If it is 10, stop. It won't say add 10 and stop. Do you understand? So that is how the second line of code works. And the last one is starting from 1. It is stopping at 9 and it's jumping every 2 intervals. So 1, 3, 5, 7, 9. That is how it works. So depending on what you want to do, you can write your for loop to do that. The same way you can use for range to do like loop through numbers, you can also use for each loop to also go through the total number of elements in a list or total number of characters in a string. So example is languages. My list is having 4 elements in there. So it is being bounded by a limit. So when I do for language in languages, the system is going to go through languages until there's no element in that particular list. So it will print Swift, it will print Python, it will print Go, it will print JavaScript, then it will end over there because that is the total number of elements in there. If it's 50, it will run 50 times and it will stop.
Okay.
So I'm going to run that for you to see how it works. So this is how it works, and then it stops. So this is for loop bounded by a range. I want to use for I in range to also implement the same thing. So if you look over here, you can see that yes, I'm starting with I, but in here I said the length of languages. So this will give me the total number of elements in languages. Then I'm printing languages index, that number. Note, Python always starts with a 0 unless you tell it to start from 1. So if I run this line of code, it's going to give me the same result. So this time it's doing languages index 0, languages index 1, languages index 2. That is how it's working. And that's how it's printing the values for us. So you can either use this to loop through a list or this to loop through a list, depending on how you want it. So you can use any one of them. Do you have any questions? Okay. The same way we did for list, you can do the same for string. Like I said, a string is a collection of characters. So you can do for X in Python. That means Python. That's bounded by a range. So it will print py. Once it reaches n, it has ended. It is done with all the characters available. Then it ends over there. So that's how for loop works. You can use it however you want to do your own implementations. So yes, that is an example. We'll go further into this on how to use loops to build a system. And I'm thinking it's right after while loop. Well, oh yeah, it's right after while. Okay. So for loop is similar to for loop. The only difference is while loop is based on a condition. So until the condition is met, don't stop. That's how while loop works. So if you are building a while loop and you're not careful, you might end up exhausting your memory and the system will just crash. So you have to pay attention when you are building while loops. Most of the time, the compilers have a safe net in there, so it will crash the compiler, not your laptop. Well, it depends on the program you're using to. So, this is an example. I initiated a variable over here. So I have I equals 1, and I have my limit n equals 5. Now, my condition is saying that while I is less than or equal to n, print I. And in here, you can see that I have done I equals I plus 1. But before I continue, I want someone to tell me what other way I can write I equals I plus 1 before we continue. We won't execute the code until we get this part right, because we've already touched it. So anyone can step in and help me do addition assignments.
Sir, I is equal to I plus 1 is just used for increment to increment
Yes.
the value. It is used to increment the value of I. So whenever the loop will run, after the loops, the value of y will increase.
Yeah.
So that's why we use I is equal to I plus 1. And I hope you have asked this question.
Yeah. Yeah. So if we run this code right now,
yes, it will run, no error.
Yeah, it will stop at 5 because the condition will check
Yes, sir.
if I is less than or equal to n before it runs the condition. So it starts with a 1 that has been defined here. If you run the code, 1 is less than or equal to 5, so it will print 1 for you, which is I. Then I will increase by 1, which is the I plus equals 1 that we have at the bottom. So now I becomes 2. While loop will run again, and I will become 2 is less than or equal to 5. Then it will print 2. It will do that until I is 5, where it will say I is less than or equal to 5, which is true. So it will print 5. Then I will increase to 6. Now, when we check the condition, 6 is greater than 5. So the while loop will break at that point. So that's how while loop works. Are we all on the same page? Thank you very much, Mohammed.
Yeah.
Is it clear or you have questions?
I think it's clear.
Let me jump here. I didn't want to run this, so I didn't create a code environment for it. But over here, I said age is equal to 32. Then the condition is saying that if age is greater than 18, print you can vote. What do you think will happen if you run this code? Age will always be 32. That means it will always be greater than 18. So every time the condition checks if age is greater than 18, the condition will be true. So it will keep printing you can vote till you run out of memory. That is how it works. So you have to be very particular when it comes to while statements. If you're not confident, if you're not confident, I would suggest you don't. There's for loop that you can bound yourself by range and it will stop when your time is up. So our first exercise is here. And this, I'm basically asking to build an addition calculator that adds every number that is inputted into the system and generates a result. When 0 is entered, it stops. So who's going to work on it? I want someone to do it live on their machine. I'll stop sharing and you show us how you approach it. So I have done some skeleton stuff here for you. Total equals 0. Number is equal to the input that you would provide. And we've already gone through this. So we convert the number you input into an integer. Now the while loop begins to run, and the value would be, and the condition is to check if number is equal to 0. So when you enter 0, that's when this while loop will break. Until then, this loop will just keep adding every number you add, every number you add. So if you type 2, it will add 2 to total. If you type 3, it will add 3 to total. If you type 4, it will add 4 to total. And when you enter 0, it will print your answer for you. That is how the system is working. So can someone build this for us on the call? This will be our second Python program. If you want, I can type it and you can say it and I'll type it. That's also an approach. Who is going?
So let's do total equals 10.
Okay.
Then number equals integer. Then we'll enter the number.
Yeah.
Let's say add numbers until number is 0. Okay, add numbers until, no, somebody should help me. I'm really thinking. I'll come back.
Okay. Anyone?
Sir, I think there is no need of a total which you are putting here.
What do you think?
Sir, I'm doing on my own interpreter.
Oh, okay,
Once-
okay. So do
Once
you want
I
me to stop
complete
sharing
it,
my
so
screen
I
so
will
that you
share
share
it.
your screen?
I will share it in the chat box.
Oh, okay, for sure. Anyone? We can also be working online while see works on this. So who wants to help Pastor Ivan? Hello. Hello. Who wants to help? Start calling.
Okay, so let me make an attempt.
Okay, for sure.
But I won't be very certain. I'm just reading what is right there.
Yeah, definitely.
So using a one build an addition calculator, I believe, that adds every number that is imputed into the system, generate a result when 0 is set. So if total is 0,
Yeah.
I'm just going by total is 0, right?
Okay.
Number is equal to int input enter number. Right?
Yeah.
So while number is not equal to 0, or what you still have there.
Yeah. So now we are implementing.
Okay.
What do you want to put in there?
Num or number.
Yeah.
Plus equal to total.
Okay. Total.
Then print.
Okay. 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 Let's. Should we run?
Yeah, let's see.
What numbers? You can list your numbers. Okay, 5.
Sorry.
Sorry. The loop is running and something is wrong. Any? Yeah. So where do you think you were wrong? Yeah.
Line 5, right?
Line 5, yes.
That is what the issue is.
Okay. So what do you want to do?
Check my answers in the chat box.
What do you say? Oh, okay. All right, cool. Okay. All right. So shall I run? Okay.
So I think that's on comments the number outside the loop. Oh,
It's already on comment. Or you want me to comment that out?
Oh yeah, sorry. No, I think he's commenting that. No, it's okay.
Okay, so starting. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, and it stops. So this works, but it's not quite there yet. Any addition? The teamwork, so
Yeah.
anybody can chip in.
So why don't you replace the print total? No, the last side, the 8.
Yeah. Okay.
Instead of the
Instead of total,
yes.
I should print number.
No, I believe that can go off.
It should go out. Okay. Okay, that's out.
Because we are looking at the end of the day having what it should generate a resource when 0 is entered. Okay, so
yeah.
So we come back to again printing the number plus number, or maybe we put
okay. So
to something.
Okay, so okay. Can I give a tip? Remember when we were doing variables, I mentioned that if you initiate a variable in line 1 and come and initiate that same variable in line 2 with a different value, what you do in line 1 will be replaced. So if my line 6 is adding the values we are getting from numbers, and every time I enter a new number is reinitiated, then basically what will be happening down here is the same number being replaced over and over and over again. You understand?
You can also contribute.
Yes, please, I'm listening.
Okay, so I can answer. Okay. I saw I've seen another approach that I think we can use to tackle this.
Okay, also. Please, we are listening.
So while number is not equal to 0, then the total plus equals store plus equal to number. Just what the guy was it Gabriel or someone did, just inverse. No. So you comment out the number in the you comment out the number in line 5.
Okay.
You comment, sorry, yeah, you comment the number, yes, and it becomes total plus equal to number.
Total plus equal to number.
And you comment out the print F with the print pointer string. Yeah.
That's right.
Yeah.
Okay. 1.
Okay, if you want to print, yeah. Okay, you want to keep
you have checked an infinite loop.
Oh, you want to keep adding? Oh.
the condition.
Yeah.
Sorry,
keep
the
adding.
program says it will calculate the sum of numbers until the user enters 0. So
give me a second. I didn't even.
I want to keep so. The reason we have total equals 0 here is because the variable total is supposed to store your summations. Yeah. So yes, this line of code is correct, but this should not be commented out. It should be in there.
Need the number. Yes.
You would need yes, exactly. You need that in a loop. So if you run this line of code now, you can do 1.
Yeah.
1 will be saved into total. You can do 2. Now it becomes 1 plus 2. You can do 3. Now it becomes 1 plus 2 plus 3. 4, 5, 6, 7, 8, 9. But when I press 0, that's when it's supposed to print the output for me. So now total equals 44.
Interesting.
Does it make sense?
Yes, it does. So, how come? Is it because 5 was introduced here? I mean, how come I didn't?
Yeah. So the first one that you gave was this. Total is 0. Your input is number. And this was not in there. So we had an infinite loop at that point because there was no condition to terminate the while loop. You understand? And the second one we got was also right, but then we were summing up number plus number for each while loop run. So we're getting the summation 1, then 1 plus 1, then 2 plus 2, then 3 plus 3, then 4 plus 4, then 5 plus 5. That's what we're getting. But then what the program actually, or what the requirement of the program is asking for is for you to add every input you get. So if it is 1, it adds 1. If you add 2, it should add 2 to the 1. If you get 3, it should add 3 to the 1 plus 2. So that's what the program was asking for. So to do that, you need to ask the user's input in a while loop form. Do you understand? Now, the reason why we have 1 input outside is to initiate the user inputting information so that number will have a value. Okay, so if number starts with the value the user will provide, let's say 1, then the while loop will trigger. Now the while loop will check if number equal to 0. If it is not, it continues. Okay, so our number is 1. So it saves number and comes to get the next input. Sorry, this is wrong. It should be like this. So, I'm sorry. So yeah, so now it checks its number equals to 0. If it's not, then it comes to run what is inside the while loop. So it will add the 1 that's inputted to total. So now you get total equals total plus 1. So now total is no longer 0. Total becomes 1. Then it will come and ask you for a second input. If you put 2, it will come and trigger the while loop again. Is 2 equal to 0? No. Then it will come and add 2 to total. So now total becomes 1 plus 2. then it will come and ask you for input again. It will do that until you enter 0. So when you finally enter 0, is number equal to 0? Yes. Then it breaks. And when it breaks, it comes to print out total for you.
So is it possible you can add a range of numbers?
Elaborate.
Let's say where the numbers now become 1 to maybe 5.
Okay, so you want to implement it with a for loop.
Yeah, something like that.
Okay, so let's go. Please, Pastor, I want to show us the way.
Oh, no. I'm just thinking out loud.
Oh, yeah, you can. If you can do something with a while loop, you can do the same thing with a for loop. So, just like, so the only difference is with a for loop, you have to define your range. So for loop, you would say that I want you to add the numbers. Okay, I want you to add the number that the user inputs X number of times. So let's say for I in range, right? We put 5 in there. This is going to give you a loop 5 times, right? And in there, we can have this thing happening. The only thing is we don't have to put a condition to end. We don't have to put a condition to end the loop, because once the loop goes 5 times, it will stop automatically on its own.
Yeah.
Do you understand? So that is how you can implement this using a for loop. I think no. I'm going to initialize it. Oh yeah, okay. So ask me to look for it. Okay, so with this, you can even execute it like this. So you run it. So 1, 2, 3, 4, 5, and it gives you your answer. Does it make sense? Hello? Hello?
Hello?
Yeah.
Yes.
Does it make sense? Okay, thank you.
Yeah, but can you explain why you have print and then the brackets F?
Okay, so that is so remember at the top I said something that ignore how the print has been implemented, because it's using string formatting. So there's something called f-string, and f-string is a method in strings for more like customizable print statements. So with f-string, right, I can do something like you can do something like this. Yeah. And let me comment this out so that we don't save 5. So with this, if I run, it will say the total number added is 5. Do you get it? You can implement this same thing in a different way, where you do something like this. Yeah, and do comma. Okay. Sorry. Yeah. I just comma. Again, please, can you confirm if I'm doing this all right?
Yeah, coming. Sorry, I was doing something.
there's a way of implementing this. I tend to do the S string more because it's more straightforward for me.
Okay, for the yeah.
What
If
did
you
I
want to
miss?
add, no. Hold on, can I see? Like where are you?
Okay.
Right, I
Yeah.
can't see.
Yeah. What did I miss?
Are you at 4 loops right now?
Yeah, this is where I'm working right now.
Wait, Python 4 loops. Okay. No, I think now the new Python, you don't need to add the percentage s. You just have to you can delete it and just do a comma in total. It will work.
Oh,
Yes.
okay,
You don't need
cool.
the percentage s anymore. Yeah.
All right. Then in the previous
Yeah, I
version
can
of
just
Python, you do
yeah, you
this,
have to do the yeah.
and because
Default.
I think I'm using 3.9, so I'm pretty sure it's 7 downwards. I'm sure
Yeah.
most of the people that did the setup are using the 3.12, so you should be good on that. But most of the time, we do a percentage D to represent numbers and percentage
Yeah,
S to
in
represent strings.
yeah.
So when you do it like this and you do a comma and you print, and it will help you, like, it will help you out.
I think the new Python, the updated versions, they don't use
Yes.
the percentage anymore.
All right. So that is why I use the S string. So it's just to help you type in your normal string stuff and also include a variable. So total is a variable. If I don't bring this curly bracket, it will
Okay.
treat total as a normal string. You understand? So that is why I use the
Stephen,
yeah.
put it into brackets and and put a percentage before the brackets, the total. Put it into brackets.
I should put
So
total in bracket.
the last one, yeah, and put a percentage before that.
Okay.
Yeah. So you can also use a percentage D if I think that is what I'm
So
seeing.
it's expression error.
No, and use no, don't add a comma. Don't add a comma. No comma. Don't add a
Okay.
comma.
All right, good. Thank you very much. So this is how this was the old style. This is how we usually handle these things. But then they introduced the F string, and it's a lot more simpler than that. So most of the time, it's the F string that I use. It's a lot more simpler. So it is more easy to understand. So you put in the total number added is that you place your variable there. You can add as many variables that you want. Sometimes you can even trigger a function in there and it will work. So that is why I use the F string. Is it clearer now?
Okay, would they have generated the same output if you had it, for example, friends into brackets, double quotes, you have the total number added is, then you space it, then you put the variable. So if you can write it somewhere.
Wait, come again. So are we talking about the first one or the second one?
Let's even the first one. Let's take off from the first one.
Okay. Yeah. So without or with the F string.
Without an F string.
Okay.
Then take the curly bracket with the total from the string.
Okay.
Then you come out of that double quote.
Yeah.
Space it.
Space.
And can you put a variable total in there and it will still work?
All right. Total. Let's
Yeah, there should be a comma before the total.
no.
There should be a comma. No,
Do
there should
you
be a
want me
comma.
to add a comma?
Yeah.
I
it
do
will
you
work.
want me to add a comma?
Maybe equal to sign or something. Just or maybe you bring
Let's see
however, I
what we
just
get.
want to see if it will pick something.
This is an error.
Why?
If you put a comma, this gives you something. Print statements. Okay, all right. Let me do this. If I approach it from print statements point of view to be a bit confusing. So let's say we have a variable. We have total over here. If we are assigning another variable directly to v, we can do this and it will work fine. If you do Python pays attention to like it takes into consideration spaces. So if you are even command prompts, that's the same thing. So if you have an input with a space, no, before I go there, so you can't even create a variable with a space. You can't do v space w. That would be an error, right? So most of the time, if you want to put two words together, you use underscore to create your variable. So this is seen as one. That is how it works. So if I do v equals and I put my string there with a space and total, they are seen as two separate entities, right? And that is why we are getting an error for that. Do you understand? So even if we try to print and it's in that format, we will have an issue. But then if we use the print statement and put a comma there, it is being treated as, let's say, parameters that feed into the print method, right? So that case, it will be able to like run and print something out for you. You can also do something like this. Concatenate. But then total is an integer. So if you try to run total alone, it will give you an error. If you do this, you are basically telling Python to add the first one and the second one together. This way, when you print v, it will print total number added is, and that information will be there. So v. You see, you get the same thing. So the issue right now is to not have like an empty space just sitting there. Does that make sense? Hello? It makes sense. So are we all on the same page? So yes, you can use string in printing. You can use string in actual scripting. So maybe you are creating a variable and want to assign a complicated string format. You can use string in there and it makes your life easy. So I'll push for string. And even in the recent version, you can do a function implementation in string and you won't get an error. In the version I'm using, it will give you an error, but 0.12 is an update. So it will run perfectly for you. So this is the solution to the problem that we just solved. And as you can see, we all got the same thing. And we've touched on infinite loops. So there's something. Yeah. Hello. Hello. Pastor Evan, did you call me?
I think the person dropped.
Oh, okay, cool. All right, so I'm going to go a little bit faster. So let me know if something is unclear then. I'll slow down over there. So we have break and continue. These are keywords in Python that you have to pay attention to. And they usually work only in loops. So if you have a loop and you have a condition, check if this and this, and the condition is met, you can use break to break out of that loop. So you can see in this example, it checks if I equals 3. If I is equal to 3, it breaks and the script ends over there. If you use continue, if I is equal to 3, it will jump over 3 and it will come and print the rest of the stuff. So it will do 1, 2, 4, 5 instead of 1, 2, 3, 4, 5. Do you get it? So that is how break and continue works. So if you want to write a condition, okay, check this and this and this, but if this condition is met, continue, don't do anything for me. You do it like that. If you want it to do something for you, you put in a line of code and it executes that for you. So with this, I would have asked someone to help us with this, but since we are running out of time, I'll just go through it. So with this, we are trying to print odd numbers. and we are making good use of the modulo function. So if you run this, you realize that we are starting from 1 and we are jumping to 3, 5, 7, 9, and we are using modulo of the number. So yeah, so we are saying that if modulo 2 equals 0, then you continue, but if it is not, print it. So 2 modulo 2 will give you 0, modulo 4 will give 4 modulo 2 will give you 0, 6 modulo 2 will give you 0. Like all the even numbers will give you 0, but then the odd numbers will give you a 1. So at that point, the foundation is not met. So you can just print out the value that you want. So that is what is happening over here. Then there's Python functions. Functions are more of a block of code, and it helps you to specify like the kind of tasks you want to do. So like the way we have this implementation over here, we can put this in a function and maybe make this an argument that is passed into the function. So if you run the function and you pass into the function like 20, the value in here will become 20. So the code will run that, so it's 20. So that is how a function works. And this is how you declare a function. So you use def, you put your function name in there and you put the argument in there into brackets. You can also have a function without an argument. So I'm going to go show you an example. So this is an example of a function where I'm saying that here's an empty, here's my function with no argument, and I want you to print hello world. So with this type of function, if you call it or if you run it, it will just give you hello world. So if I print this, sorry. Okay, now if I run this, it says hello world. Okay, so the reason why I initially got an error is because I hadn't declared the function. So greet didn't exist. The compiler didn't know what greet was. So after I ran that bit and I ran greet, now it's able to tell that greet is a function that contains print hello world. So if you if you call it, it does exactly the block of code that is within the function. This is an example of a function that takes in an argument. So I set this function to take in number 1.
Stephen.
Yes.
From a little bit of my experience, this is a very critical component of what we are doing. So
yeah,
I would suggest that the function side, if you can slow down, it would help.
Okay.
Because if we don't get the concept, trust me, it's going to mess a lot of things up.
I agree with you.
Yes, and I would wish that you start it all over from the functions again. It would help.
All right. Okay, I will do that. Okay, so I'll take my time there. This is, like Isaac said, is a major component in Python. A lot of programs that built are dependent on functions. Yes, there are classes and all, but classes also depend on functions because most of your methods and implementations are all function based. We'll touch on classes tomorrow, so you'll have a good understanding of what I mean by classes. But basically, functions are a block of code that perform a specific function. And this is how you declare a function. So you use def, the name of your function, and you put in an argument. You can have a function without an argument, and that is perfectly fine. And when you introduce an argument and you run the function without the argument, it will give you an error. So these are all things you have to take into consideration when you are working with a function. So I try to do like a breakdown to be able to understand the components of the functions. So def is actually a keyword that is used to declare a function in Python. So if you type def and you run it, the compiler automatically understands that, okay, anything that comes after this is supposed to be a function. So it is critical to start your functions with def. And the function name is whatever name that you want to use. And it is advisable, or it is best to use a name that is that explains what you are trying to accomplish. So if I want to do and build a calculator, my function name should be calculator. So that if I want to like trigger the function later on, I know that, okay, I want to trigger the calculator. So you just trigger the function name calculator and it will do exactly what you have asked it to do. Now the argument is like the values that you pass into your function. If you call your function name and you have values assigned to it, that means you have like critical variables in the function that needs certain user inputs to be able to function the way it's supposed to. So if, again, I'll use a calculator as an example. To use a calculator, you have to enter the numbers. So you have to enter, let's say, if you want to do an addition, you have to say 1 + 2, and it will give you a 3. If you don't input any value, your calculator will not do anything for you. So that is how arguments work. So if I say an addition function, my addition function is supposed to take inputs. And if I put in the inputs, it goes into the function and it will do with it what you have asked it to do. So I'll touch on that when we get to the argument bit. But over here is a function without an argument. So you can run it you can have anything happening in here and you won't have a problem. So you can even initialize a variable in here, maybe 2, and print 2. Whatever you do in this function, it will run. You don't have a problem because you have created a function without an argument. But if there's no argument and I put an argument in there, I'll get an error. Why? Because this function takes 0 positional arguments, but 1 was given. Do you understand? And if this function takes in an argument and I run it without an argument, it will give you an error saying missing 1 required positional argument. Do you understand? And it's also advisable to make sure that the argument you provide is explaining the kind of information that you need. So if I say something like S don't make sense. So in this error, it says S, how do you know that this function is supposed to take maybe a particular type of greeting? Do you understand? So if I say S and the error message comes as S, how do you know? But if I say something like greeting type, when you are trying to the foreign user, when you're trying to run the functions, right? And you trigger this, it will tell you greeting type. I said, oh, okay, let me see. Good morning. Good morning. Then I know that, okay, that's the greeting type. So when I run this, it will give me good morning. Sorry, I haven't triggered that in here, so it won't do anything, but it will give you good morning as you are next. Is this a good place to stop? Because we are out of time, or you would want me to finish the whole function topics before we close? Hello, guys.
I don't mind if we can finish it.
Okay, so then I would, if we are all on the same page, then I would complete the function topics, then we will continue tomorrow and touch the other areas. Another thing you can do with function is you can actually define the data type for your function. So greetings, I want greetings to be a string. So you set it like this. If I put a number in here, I'll get an error. Why? Because this function only takes a string.
Do you mean to say that if you want to define the data type of your argument?
Yes.
Okay.
Yes, that is what I'm trying to say. So in your function, you know that, yeah. All right. So and implementation that's, let me use things here. Say 3 course. Right. Okay. So okay. This. So in here, we know that your function is supposed to take an integer as that's been defined over here. So if I run this, it will give me the input, which is 1 plus this one, and it will be straightforward. Because what you've done in there, you are not casting anything, everything is being treated as numbers. But if I provide a string here, it will give me an error because you can't concatenate, you can't add a string and an integer. So you get an error over here telling you that the type you have is not what the function requires to operate. So then you know that, okay, this helps you to control the kind of inputs that you get. You can do the same thing for lists. You can do the same thing for dictionaries. So with this, you know that your function only takes dictionary. And whoever that will be working with your function will be able to tell when they check the pop-up, like using IntelliSense to check the pop-up for that particular function. They can tell that, okay, this function takes in a dictionary. You can also set your function to return a particular type of the output. So let's say I want my function to only give me strings as like return strings as an output. So over here, you can see that the function takes in a dictionary and it will output a string for you. So that is how it works. So it depends on your use case. You can tell your function to do or act however you want. I think I'll go deeper into these things as I go down. So this is an example of a function that takes in a parameter. Also, you should know that your function can take in as many parameters as you want it to take. And it's also advisable to have smaller functions. Your function should be specific. So if you want to do addition, let the function do addition. Don't let the function do addition and subtraction. I'm not saying you can't do that. You can do that, but it is best practice to make your functions more specific, because that way you can easily call each function to do whatever you need it to do when you need it to. So if I want to do an addition, I just call an addition function. If I want a subtraction, I call a subtraction function. That's how it's best to handle functions. So this is an addition function, and in here we are just taking 2 arguments. So that's what this function does. It doesn't do more than 2 arguments. So it takes in n1 and n2, it sums them up and it prints out the file. You can specify that this should be an integer. This should be an integer. And it should give me an integer as a return value, right? Then in here, you can return sum. So that's how this function will work. So if you run add numbers 1, 2, you see it takes in num1, it takes in num2, int, and it will give you an int. So if you run this, then it will print out 3 for you, because that is what it's supposed to take. But if you set it to string, I think it will give you an error. Okay, cool. That's interesting. But let's check the type, if the type was changed. Still an int. Okay, that's interesting. I'll look into this and I'll share more information on this tomorrow, why we are getting this. But basically, this helps you to set your function to return a particular type of output. So whoever that will be working with your function will know that, okay, this function takes in 2 integers, and it gives you a string as an output. That's how it works. Or this function takes in 2 strings and it gives you an integer as an output. It makes people to work with your function. Note that most of the time when you are building programs, you're not building for just yourself. You are building it for people to maybe use or interact with it. So you always have a need to make sense, have comments in there and all of that. So basically that's how functions work. This is a more detailed breakdown of functions. So with this, you can have a function that has default values assigned to them. So with this approach, if you provide a value, A and B will be replaced. But if you don't provide it, A and B will use 7 and 8 as default. So you can see over here, I said add numbers 2 and 3. So with this, A becomes 2, B becomes 3. When you run this, it will sum up 2 and 3 for you and give you 5. If you go with this approach, you need to either take into consideration, if you are doing this approach, you have to always try to initialize the arguments that you're assigning to. So as you can see over here, I'm saying A equals 2. So with this, the Python compiler knows that this function is replacing the value for A. So A will be equal to 2, but B will still be 8. So that's how this will work. If you want to do only B, you just change A to B and it will know that what you are changing is only B. And then there's this without any arguments. When you call this, it will maintain things as it is and it will work. So this is a special case with what I have touched so far at the top. If you call your function, if your function is supposed to take in arguments and you call without arguments, it will give you an error. If it's not taking an argument and you call with an argument, it will give you an error. But with this special case, you are defining the values ahead of time. So if you call with or without an argument, it will still run because that is how you have designed your function to operate. Is that clear? If you have any questions, let me know so that I go over it again. Hello. Hello.
Hi.
Hello. Yeah. Any questions? Or we are all good?
I think good for now.
Okay. So, and this is also another type. I think I've touched on this again already. If you are defining the arguments you are assigning to, you can misplace them. Like you can place them in different position, you will have a problem. So this function originally is taking first name and last name. If you are calling display info, right, and you just put in, let's say, HH and BB. By default, Python will treat HH as first name and BB as last name. That is how Python operates. So if you reverse the position, you've made a mistake. But then if you define it like the way it has been defined up here, the last name, first name, it won't matter what position, even if middle name is at the end, Python will still be able to tell that first name goes to the beginning, last name goes to the end. So this is also another way to call your functions. So depending, it's up to you and what you're trying to accomplish.
So,
then,
yeah. If I do understand you, so that means that how it would display is totally dependent on how you have declared it. Right?
Not necessarily.
I was thinking in the declaration side of it. I mean, you have first name coming before last name. So if
Yeah.
I am calling it and I even call the last name before the first name, somehow it would still would invoke first name before the last name.
No. So the function is doing what you've asked it to do, right? So first name. Over here in this function, I'm telling it to print first name first, last name second. That's what the function is doing. Okay. So if I run this function with this HBB in mind, let me use my actual name so that it makes sense. So Owusu is supposed to be my second name, my last name, sorry, and Steven my first name. Okay. If I reverse the position like this and I print this, it will give me Owusu Steven. Because Python has defined Owusu now as my first name and Steven as my second name. Sorry, Steven as my last name. Do you understand? But if I go with this approach, it won't matter the order, whether Eric came first or Eric came last, it won't matter. It knows that first name is Eric and last name is Katman. So if I run this, first name is Eric, last name is Katman. If I reverse the rule over here, last name first, first name second. It will do the exact same thing. So that's what happens. Does it make sense?
Yes, it does. It's okay.
Beautiful. Then there's this bit. This is a bit more complicated, so I'll need your attention. So what we've touched on so far is a function taking specific number of inputs.
Stephen, sorry
Yes.
to come in anyway. If this side is really going to be a bit more complicated, then
Let's
the
move
same
to tomorrow.
person, well, yes, I move that we move it to tomorrow.
All right. Okay. Then let's do that.
I think we are entering the deep waters.
Yeah,
Yeah.
it's getting deep. Yeah, so we can jump, call it a day, and meet tomorrow 10.
Yeah.
And go through real quick. Tomorrow, I think after functions, we'll talk about libraries, Python models. We'll do one complicated project. So hopefully everybody is able to set up Python on their machines before tomorrow's meeting. If you have any challenge to, please send a message in the WhatsApp chats and I'll help you set up. Then once we are all good to go, tomorrow we will do this. I really enjoyed working on this challenge. So I'd like to see how all of you will approach this particular project. Then from there, I would touch on what variables are. I mentioned this at the beginning when I spoke about variables. So we have local, global, and non-local. Then we'll look at the different data types, how to end the methods under it. So you know about the different numerical data, you know more about strings, how you can manipulate strings, so string operation, comparing strings, checking the length of strings, all of that. And you get to see uppercase, lowercase, splits, all of it. Then I'll touch on lists. I'll touch on dictionary. I'll touch on tuples. I'll touch on sets. I'll touch on everything. Then we'll be done with this. Once we are done with that, we'll go to day two. Day two's content, which is object-oriented programming. So we'll do that. That is classes, and it gets interesting. And once we are done with classes, we'll go into data analysis, and we go into real machine learning algorithms. So I'm looking forward to this. I hope everybody was able to learn something. See you.
Yes.
Pastor Ivan, over to you.
Yes. So thank you very much for today.